This video, I will explain how to do a directional one sample t-test on SPSS and how to calculate the correct p-value based on the one-sided p-value output that we get. We will use this data set of students, of Bakersfield College students, everyone who answered our day one survey. We'll use it as a sample of BC students in general. So our hypothesis will be that BC students study more than 8 hours a week. That's our research hypothesis. All right. So if we were to write this out in statistical notation, our research hypothesis corresponds to our alternative hypothesis, which is that the mean study hours for BC students is greater than 8 hours a week, 8 hours. Therefore, our null is that BC students study less than or equal to 8 hours, all right? So right here, we have what will become our test value, 8. So to test this hypothesis, we select Analyze, Compare Means, One Sample T-Test. We can right-click this variables field and select Display Variable Name, so it's easier to see study hours. We move our study hours into this test variables field. We need to change our test value to 8 because we are hypothesizing that BC students study more than 8 hours a week. And so our test value will always be the value that we have in our hypotheses. All right, we click OK. Now I'm going to change my sharing so you can see the output. Okay, here are the results of our one sample t-test. Our first step is to look at the mean of our sample and determine if we are correct in hypothesizing that it was greater than 8. Here's the mean. The mean is 9.297, so we are correct. The mean for this sample is greater than 8. Can we infer anything about the population of BC students based on this sample? For that, we have to look at our p-value. Right here, we have it in SPSS where it says significance. We look at our one-sided p-value. So we are using, I forgot to specify this, we are using an alpha value. If our alpha value is 0.05, then we reject the null hypothesis if p less than 0.05. So our p-value is 0.036, which is less than 0.05. So we can reject the null hypothesis and conclude that BC students study more than 8 hours a week. We would write this out. We would write Bakersfield College students study more than 8 hours a week, comma, T, parentheses, degrees of freedom, which is 90. All right, we can see that right here, equals, we put our T value in, which is 1.833, P equals, we always put what it actually is, equals 0.036. Sometimes we write a subscript T one-tailed or P one-tailed, right? And then we could write our effect size, Cohen's D, that's a D, equals 0.19. This is right here, okay? Okay. That was an example of a one sample directional t-test when we were correct in our hypotheses and found that the mean was, as we hypothesized, greater than 8. Now I'm going to show you a different example. This time, we're going to make a hypothesis about the mean hours spent on social media, how many hours Bakersfield College students spend on social media. And we are going to hypothesize that Bakersfield College students spend less than 10 hours a week on social media. Okay, so we're going to write that out. If we hypothesize that Bakersfield College students spend less than 10 hours a week on social media, our alternative hypothesis is mu is less than 10. It's a directional hypothesis. Our null hypothesis is that mu is greater or equal to 10, right? So we can then run the t-test. We select analyze, compare means, one sample t-test. We remove study hours, and we're going to put social media hours into the test variables field. We must change our test value to the one that is in our hypotheses, which is 10. We hit OK. So here's our output. Our first task is to verify whether we were right. For us to be right, the mean for our sample has to be less than 10. Here's the mean from our sample. It is not less than 10. It is greater than 10. So right there, because we're using a one-tailed test, we know we must fail to reject the null. Okay, we fail to reject the null because in a one-tailed test, if the direction is wrong, we automatically must fail to reject. Okay? Now, we still need to be able to report this, okay? We still need to be able to say what the mean is, right? When you say the t-value. So we would say Bakersfield College students do not spend less than 10 hours a week. More correctly, we would say there is no evidence that Bakersfield College students spend less than 10 hours a week on social media. And then again, we do t parentheses, degrees of freedom, which is 92 in this case, right? 92, right there, equals 2.12 P equals, okay. So in this case, again, that's our t value there, that's t. We need to look at the one-sided P. But because we were wrong, this is the wrong tail of the distribution, right? So to get the correct p-value, we must subtract this value from 1, okay? So p is going to equal 1 minus 0.019, okay? So p is going to be equal to 0.981. Now, if you cannot do this in your head, you can do it with your phone calculator. You can do it in Google, or you can do it by simply subtracting by hand as you learned way back in grade school, but you might not remember. To do this, you line up the decimal places. Okay. Then you have to move this over. Okay. I don't even remember the terminology for this, but we do this. That's a 9. We make this a 10. This is a 9, right? We just move 10s over. This is a 9. This is a 9. And this is a 10. 10 minus 9 is 1. 9 minus 1 is 8. And 9 minus 0 is 9. Okay. So here it is. P equals 0.981. Okay. Now, if we wanted, this is the wrong direction. This is still, D is still a measure for the differences between the mean. Okay. But this will be negative, of course, because we're not in this direction. But it's pointless to talk about this right now because we have a non-significant result right here. And that's all you need to know for the level of this course.